I would like you to start by looking at the page called Speeding Through the Lines. This is a review of what we did on Friday with the characteristics of linear functions. You'll be given 2 points and asked for an equation. You're given an equation and asked for the x and y intercepts. You're given the slope and y-intercept, you're given an equation and asked for the slope and y-intercept. So if at any point in this page that you struggle, it might be a really good idea to go back and look at the notes that we took on characteristics of linear functions. But for now, what I want you to do is circle number 1, 3, 5, and 7. I'd like you to circle problems 8 and 10. And I'd like you to circle problems 12 and 14. Those will be the problems that you are responsible for tomorrow. As always, if you do extra, that is extra points. But these are the 8 that you'll be responsible for tomorrow. Okay? The next page is called Linear Inequalities. If you'll turn to page 3 of 4, see down here at the bottom it says page 3 of 4. It's also the one that says practice problems right up here. Oops, practice problems. On this page we're going to circle 2, 4, and 6. You're going to circle 8, 9, and 10. Okay? Again, the ones that we circled are the ones you're responsible for tomorrow. The rest you can do for extra points if you wish. Okay? However, we do need to take some notes on this paper, don't we? We need to fill some blanks in. The expressions above are called linear inequalities in 2 variables. Why? They each have 2 variables. That seems pretty obvious, but guess what? It is. Right? So why are they called linear inequalities? We got the 2 variables parts. They are not equal. The graphs of linear inequalities involve 2 things. Do you remember what those 2 things are? And I'm saying remember because this is still a review of linear functions. We have a shaded region. And we have a boundary line. Does that ring a bell? Good. So here are the steps. First, we're going to solve for y. Okay? Some of the equations might be in a type of slope-intercept form. Keeping in mind it's not exactly slope-intercept form because slope-intercept form is an equal sign. It's an equality, right? We're talking about inequalities here. But we have to solve for y. However, what must you do if you multiply or divide both sides of an inequality by a negative number? Do you remember? Do you remember that you have to flip the inequality sign? Do you know why you have to flip the inequality sign? Or have you always just been told you have to flip the sign? I would like you to know why. Okay, so I'm going to take just a minute, really quick, and show you why. Okay? Can you see that at all? Great. Let me grab a pen. 4 is less than 9. Do you agree with that statement? Okay. What if I add 3 to both sides? I get 7 is less than 12. Is that still a true statement? So if I add something to both sides, that doesn't change the value of the statement, does it? Well, what if I subtract 5? Is 2 less than 7? Is that still a true statement? So subtracting something from both sides doesn't change the value, right? What if I multiply both sides by 6? Is 12 less than 42? So if I multiply both sides by a positive number, that doesn't change the value, does it? What if I divide both sides by a -2? Is -6 less than -21? Does that help it make more sense why you have to flip the sign? I mean, there's a big rule I could read you about why you do, but I'd rather just be able to show you an example and have it make sense. Is this okay? Does it matter if you multiply both sides by a negative number? We were here, right? 2 is less than 7, and we agreed that that was true. What if we multiplied both sides by a -6? Is -12 less than -42? No. So whether I divide, like I did here, or multiply by a negative number, that's when I have to flip the sign, because this is no longer true. That's not true, and that one's not true. Is it? Do you have any questions about why we have to flip the sign, when the inequality sign, when we multiply or divide by a negative number? Good. If you do, ask me. It's okay. Okay? I'll finish filling the rest of this in pen. I apologize. I didn't realize how light it was. I fixed it yesterday, but now it's back again. Okay? Graph the line is what we have to do next. When we graph the line, we use the blank and blank. Slope and y-intercept. Very good. Use solid lines for something and use dotted lines for something. There's two inequality signs that we always use solid lines when we graph the line, and two inequality signs that we always use dotted lines when we graph the line. Less than or equal, greater than or equal. We use solid lines. Dotted lines is less than and greater than. So how are you going to remember that? If there's a line underneath it, it's a solid line. If there's not a line underneath it, it's a dotted line. And there's been a little bit confusion. So let me make sure that we all are okay. Some people said, could we use dashed lines instead? So I'm here to tell you right now, dashed lines and dotted lines are going to be the same. Okay? Some of you are laughing. I am also laughing inside of my head. Okay? But I want to make sure that our vocabulary is the same so we understand what we're talking about, right? Okay. After we solve for y and after we graph the line, then we have to pick a side. Okay? Some of you are really good at doing that, picking a side. Select a point on one side of the line to test by plugging it into the original equation. So we're going to pick a point. Usually we want to choose 0, 0 because it's the easiest. Okay? Mathematicians are nothing if they're not lazy. And that's not always a bad thing. We want to find the short way to do things instead of always having to do it the long way. Choosing 0, 0 is the easiest, so choose that. Is there any point where we cannot choose 0, 0? Unfortunately, the answer is yes, and you are correct. If the line passes through 0, 0, we cannot choose it. We have to choose some other point as our test point. Okay? I would recommend you choose a point on one of the axes, because then one of your values is still 0, either your x or y. Okay? So, if we take our test point, in this case 0, 0 if possible, and we plug it in and the final statement is true, we want to shade that side. If we plug in our test point and the final statement is false, what do you think? Shade the other side. Okay? I would like to do 2 examples for you. One is called A and one is called B. Okay? So let's start here. First step it says is solve for y. Okay, done. Right? Y is already solved for us. So our next step is graph the line. How do I graph the line? I use the slope and the y-intercept. What is my y-intercept here? 3. Where do I go? Up 3 on the y-axis, correct? What's my slope? -2. My slope has to be a fraction though, so I have -2 over 1, right? So I'm going to fall 2 and run 1. Fall 2, run 1, fall 2, run 1, and so forth and so on. But I could also rise 2 if I ran backwards 1, right? Rise 2, run backward 1, rise 2, run backward 1. Whatever I'm trying to say. Oops. What kind of a line is this? Solid line or dotted line? And you say solid, right? Because it is less than or equal to. And if it's less than or equal to, we choose a solid line. Choose a point. Which point do we want to choose? 0, 0. Does the line pass through 0, 0? So we can choose it, right? So when I put 0 in for x and a 0 in for y, I get 0 is less than or equal to -2 times 0 plus 3. What is -2 times 0? 0. I get 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes. This point is true. If the final statement is true, shade that side. Done. Questions? So what about B? What do I do first? Solve for y. Is the y solved for this time? No, I got to get that y by itself. How do I do it? First step, subtract 2x from both sides. So I get -3y is greater than -2x plus 6. Now what do I do to solve for y? Divide both sides by -3. So here I have -3 divided by -3, which equals 1. So I just end up with y. I did divide both sides by a -3. So yes, correctly, you're saying flip the sign, flip the inequality sign. So it's not a greater than anymore, it's a less than, right? then each term on this side I have to divide by -3, right? That's what it means when I write it underneath that whole side. So I have a -2 divided by -3. I can just leave that as a fraction, 2/3, but it is a positive, correct? X, 6 divided by -3, -2, or -2. So when I go to graph this on the graph, what do I do first? On the y-axis, I go down 2. Very good. That's my y-intercept. It's on the y-axis. From this point, I go up 2, right 3. Rise 2, run 3. Up 2, right 3. From the very first point I started at, could I fall 2? As long as I run backwards 3, right? What kind of line is this? It is a dotted line. Thank you. Oh, excuse me. Now, all I have left to do is shade. Do I shade above or below? Pick you a point. Can I pick 0, 0? Yes, so 0 is less than 2/3 times 0 minus 2. 2/3 times 0 is 0. So 0 is less than -2. Is 0 less than -2? Then this side is not true. What does that mean? Shade the other side. So, are you ready for a trick question? Of course you are. Who's willing to be brave? Kendra, thank you for volunteering. I would like you to tell me one point, only one point that is a solution to this inequality. Where are we looking for points that are solutions to the inequality? Can anybody help her out? Tell her. So we're looking in the shaded region. That's why we shade it, right? Otherwise, all it is coloring. What does it mean to be in the shaded region? It means it is a solution to the inequality. So tell me one point in the shaded region. 6, what? 6, -6? Is that point in the shaded region? Yes, so clearly we only have one answer. Right? How many answers do we have? A lot, a lot, a lot. Thank you for being brave. I know he was trying to pick on you, but what he doesn't realize is that you just got extra points. Okay? Any questions about this? Any questions about linear inequalities? Ask me. When we shade, how do we know what side to shade? Okay? Right here, we wrote some notes. And we said if when we put this value in here, if this statement is true, I want to shade where that point was. I chose 0, 0 for this problem right here. This statement was true. 0 is less than or equal to 3. So wherever 0, 0 was, that's the side I shade. This statement over here, when I put in 0, 0, that made the statement not true. 0 is not less than -2. So that side is not true, so that means the other side of the line is true. And we always want to shade the side that is true. Yes, ma'am? Can you use 0, 0 every time? Another good question. And that's the right answer. Not if the line goes through 0, 0. Okay? Yeah, I would, if you had to choose another point, I would choose a point on an axis, like anything here or anything here, because then, I mean, that's just, to me, makes it easier, because one of the values that I would put in would be 0. If you want to be a little bit off the record, I would always choose a point that has an x value of 0. So I would always choose something on the y-axis that has an x value of 0, because that'll make this 0, that part right there. It does not matter what point you pick. We just want to try to pick the easiest points. We want to make it easiest on ourselves. Any questions? Those were all good questions, by the way.